Hello, we are Group 10. We are working on hand tremor detection. We are biomedical engineering students, and my name is Anna Villegas.
My name is Teresa.
And I'm Jennifer Ardino.
I'm Eric Magro. Hand tremors are characterized by involuntary cyclic movements. The electric circuit that we designed uses a piezoelectric film, which converts displacement to an electrical signal.
The hand movement used as a stimulus in this project are a common form of tremors and are highly useful for technology regarding exercise and pathologies.
And next we will explain the clinical relevance of our project. There are several different types of tremor. The two main categories are resting tremor and action tremor. Anna will explain the action tremor and I will go on with the resting tremor now. It's a very common form of hand or finger tremor and it's caused by neurodegenerative diseases like the Parkinson disease, and it occurs at rest.
And so action tremors occur with the muscle which is being used in that specific movement. It can take a lot of different forms, like postural tremors, kinetic tremors, intention tremors, task-specific tremors, and isomeric tremors.
The hardware used includes an LM3914 IC driver used for testing the circuit with LED, the LED itself, capacitors, a diode, the TLC2274 quad op amp, resistors, and the piezoelectric sensor. The circuit was designed to utilize a piezoelectric sensor using a piezoelectric film. The signal enters a series of resistors and capacitors. The signal is amplified in the first op amp of the Quad 741 operational amplifier. The signal then encounters an envelope detector, which is made of a resistor, a capacitor, and a diode. This part of the circuit helps to rectify the signal and produce a half wave, which selects only one of the polarities of the signal, so only the positive values are kept. Before reaching the launch scope, the signal is filtered using a low-pass filter set to only filter for frequencies under 10 Hz. The signal then passes through the third op amp and the quad operational amplifier. The output of the third op amp is then passed to the launch scope for input into the laptop to the simulated oscilloscope. Here you can see a picture of the final circuit.
The piezoelectric transducer converts displacement to an electrical signal. It goes through the wire here. The signal enters the circuit and gets amplified using the first op amp in the quad, which can be seen here. The quad operational amplifier. After amplification, the signal goes to the low-pass filter here. The signal is then amplified again, entering the quad in the second operational amplifier. The signal then enters the envelope detector. After being amplified in the third op amp inside of the quad, the signal then goes to the launch scope here. The oscilloscope simulator receives information about the signal from the launch scope and displays a graph for the signal generated by the tremor.
Here you can see the signal generated by the circuit and displayed on the launch scope software. Here you can see the finalized circuit just being tested and producing a display on the oscilloscope in a lab.
One of the problems solved was determining the appropriate resistor value given the time constant and capacitor value for the low-pass filter. Another problem solved was creating an envelope detector that performed rectification of the signal, leaving just the appropriate polarity. This allows the signal to be generated that only contains appropriate components of the input signal from the tremor. Lessons learned were an electric signal can be generated solely by movement through a transducer, such as a piezoelectric transducer. Half-wave rectification can be performed by an envelope detector using the appropriate components, and testing the circuit using various equipment is necessary in order to verify the circuit components.
Future directions: improving methods for delivering the signal into the circuit, using components with lower accuracy tolerance which are less prone to variability, creating optimal sensors for those suffering from tremors.